Okay.
Okay, hi Arnav, welcome to your first chemistry class. So, what we'll be doing in chemistry grade 12 is we have organic chemistry, right? So this unit will be the lengthiest unit. Okay, you're able to hear me?
Yeah.
Yeah. So most of the time there are schools they don't start with this unit. Okay. Then we have structures and properties of matter. In that we have chapter 3, that is atoms, right? Very
Mhm.
interesting, extremely easy. It has part like you had studied some part of this in your grade 11, and this is now taking that basic and having the extension of it. Okay, so what we'll do is we'll start with this unit 2, structure and properties of matter. In that we'll start with chapter 3, then we'll talk about chapter 4. I'm pretty sure you did Lewis structures, right, in grade 11,
Yeah.
right? So this is an extension. We'll learn the Lewis structure and we'll do the extended version of it and then try to understand what are different types of models and how the structures come in. Okay. After
Okay.
chapter 4, the next is energy of changes and rates of reaction. So we'll try to understand how energy and matter interacts and how different rules are applied to it. Kinetic chemical kinetics, in this we'll try to understand how the reaction rates can be calculated, whether the reaction is fast, whether it is slow, what are the mechanisms involved in it. So that is part of chapter 6. Okay. Then chemical system, then we have chemical equilibrium. So whether a reaction is reversible, irreversible, we'll try to understand that and why these concepts are important. How do we predict the reactions? So that is taken care in your chapter 7. Chapter 8, part of equilibrium, but we study specifically acid base equilibrium. Okay. And then we
Yeah.
go to unit 5, that is electrochemistry. What I have observed is electrochemistry is a unit which at times students find difficult. Okay, especially in that the concept of these standard reduction potential. Actually, they are easy, but I have seen that students do find it difficult. Electrolysis. What we'll do is we'll structure it in a way that it is easy to understand and simple to remember. Okay.
Okay.
So
Yeah.
uh, that's your introduction to the entire syllabus of grade 12. And as I told you, I will not start with organic chemistry because it is the most lengthiest unit. And if we start now, we may not be able to finish it. Like before, like that. When is your school expected to start?
So actually, because I did grade 11 chemistry in grade 10,
Right.
um, most likely my guidance counselor who's making my schedule is going to put grade 12 chemistry in the second semester of grade 11. So
Okay.
when my school starts, I'm not going to have chemistry most likely.
Okay. Okay. No problem. Then what you want me to do?
So what I think we should do is, especially because organic chemistry is the lengthiest unit, I think it's
Okay.
good to start with that first because it's
I'm
gonna
open.
count for most of my grade. And
No
I
problem.
also looked a little bit at it, and I learned like a lot of it is like memorization, especially of the names and stuff.
There are rules, yes. The certain rules you need to memorize, but after that, once you know the rules, it is more of applications of those rules.
Okay.
Okay, so what I'll do is I'll start with organic chemistry and let me pull up my notes for organic chemistry in that case. Okay. Because what my observation with organic chemistry is that it is you can go in depth, right? And you can continue doing it forever.
So what do you think is the most difficult to understand unit for high school students in grade 12?
So, see, when it comes to difficulty level, uh, if like I honestly feel that we should start with structure of atoms.
Mhm.
Okay, because that starts the base of the uh, entire chemistry.
Okay. So
Okay, so
we can
that
start with that. I'm good with that.
okay, I just pulled out my notes for organic chemistry. It's okay. Then I'll go back to the structure of atom because it is
Okay.
interesting. You learn a lot about the history of chemistry. Okay, and
Yeah.
then because one part is the electronic configuration and the orbitals and the energy levels, right? So
Hmm.
once you know that, gradually building up with the next portion is easy. Like how the structures are written and all that is relatively easy.
Wait, so some of that stuff I already learned in grade 11, but I'm
Yes.
not sure if that's because I took AP or not.
That's fine. Like what we'll do is we'll try to cover as much as possible, and
Yeah.
whichever things you know, right, we'll not try to go in details of that, but I'll definitely ask you questions. If I realize that you know it, we'll just once I know that you know it, then we'll move to the next topic. But if I feel that you have a little bit of gap, I'll try to intervene and I'll try and explain that. Okay,
Okay, and should I take notes while you're teaching?
I'll ask you to write it. There are something like my habit is I generally ask student to write in the process. For now, just concentrate on what we are going to do. Okay.
Okay.
So the I'm giving like I'm not starting with the nature of the atoms and the molecules. I believe you know what are atoms and molecules. Can you just tell me what are atoms and what are molecules?
Atoms are the fundamental building block of life,
Right.
and I'm not 100% sure how to explain molecules because it's been a while, but I think
Okay.
it's like the configuration of them. Like there's different types of molecules like oxygen, carbon,
Right. Okay.
nitrogen, and to differentiate them like is through the like electrons
That's
and
okay. Okay.
protons.
No problem. So atoms, right? They are
Yeah,
fundamental to matter, right?
yeah,
They are not, you mentioned fundamental to the life, but okay, fundamental to the matter.
hmm,
Okay, mental to matter. So whatever you see on the periodic table are all the atoms.
oh,
Okay, then you have, so basically you have atoms fundamental to the matter, so or fundamental to the elements, right? So on the
yeah,
periodic table we see all the elements, right?
yeah.
Extension to that there is molecular elements. Okay, so molecular elements are all the Hofbrinkel.
Oh, yeah.
Okay, so what are Hofbrinkel? These are
Hydrogen,
molecular
oh,
elements.
sorry.
So hydrogen, oxygen, fluorine, bromine, iodine, nitrogen, chlorine. So these are elements, but they are diatomic. Okay, does that make sense?
Yeah,
So they are called molecular elements. Now, what are molecules? Atoms or group of atoms, right? Why I'm saying atoms as well as group of atoms, because when you have two atoms, it's a molecule. Okay,
yeah,
does that make sense?
it does. Yeah.
So you have atoms, you have molecular elements, and you have compounds. So compounds are made up of more than one element, right?
Yeah.
And if you have more than one atom, that is a molecule. Okay, so for example,
Okay.
NaCl. NaCl is a compound made up of two atoms.
So Cl2 isn't a compound?
Cl2 is a molecular element, it's not a compound.
Okay, so compounds are only different elements.
Different elements together, yes. So if I
Okay.
have HF, right? Or HCl, right? Or
Yeah.
CH4, right? These are all compounds.
Okay.
Okay, you
Yeah.
can call them as molecules. Not no, it's not wrong. Okay, but if
Yeah.
you say Cl2, you should call it as molecular element because it contains only the same element. When I'm talking specifically about compounds, compounds are always more than one element,
Okay.
right?
Yeah. I understand it.
So now you have here a molecular element, and I can say this is a molecular compound. Okay,
Yeah.
any doubt?
No, no, I think I understand it.
So you can write down atoms are fundamental to matter or elements. Then you have molecular elements and you have compounds. So the entire, what you say, matter is made up of atoms and molecules. Okay,
Yeah. So one element is also can be called an atom.
one element can also be called as atom. Uh, the purest form of it, yes, the purest form of anything is an element.
But an element can also be considered an atom,
The
right?
fundamental of an element is an atom.
Oh, okay.
So an element is made up of atoms. Okay,
Yeah.
and a compound is made up of group of elements or group of atoms.
Yeah.
Okay, so elements are substances that are made up of only one type of an atom, while molecules are group of two or more atoms. Correct?
Yeah.
And then I told you molecular elements, which is made up of more than one atom of the same element.
Wait, you said molecules are two or more atoms.
Yeah, molecules are two or more atoms, correct? But in that, I
So,
told you molecular elements, Mol-
oh, okay.
two or more atoms of the same element.
Yeah.
Okay, so I'll repeat again. Atom, smallest unit of an element, correct?
Yeah.
Molecules, two or more atoms, correct?
Yeah.
Then molecular elements, two or more atoms of same element.
Yeah.
Clear?
Yeah.
No. So we are done with atoms, molecules, molecular elements, right? Now
Yep.
let us talk about the next part. That is the development of atomic structure. So when we study about all these, first we should know what the atom is. What is the atom made up of? So everyone were pretty much interested in knowing about what is an atom, right? Nobody knew that what is the atom made up of. Okay, hello, can you hear me?
Yeah. Yeah, I can hear you.
Right. So then the first time somebody, like, there were many other scientists before Dalton, but may, Dalton's theory was the most that stood, what you say, for a long time. okay, has stood the test of time extremely well. Okay,
Yeah.
so what John Dalton proposed was that elements consist of atoms which cannot be created, destroyed, or divided. Atoms of the same element have identical size, mass, and other properties. Does that make sense?
Yeah.
Okay, so obviously they cannot be created nor be destroyed, right, or divided. Same element have identical size, mass. That means hydrogen has same hydrogen atoms will have same mass, same size, and same properties. Oxygen atoms will have same size, same mass, same properties.
Yeah.
Nitrogen will have same size, same mass, and same properties. So that was his original understanding about what are the elements, what are atoms, right?
Yeah.
Okay. But what he said, it cannot be created, destroyed, or divided, which gradually started changing. Okay.
Yeah.
That means now we can create new atoms. We can destroy the atoms. We can divide the atoms. Okay.
Mhm.
So the technology is gradually getting so advanced that we can do this, that this is achievable. Have you heard about nuclear bombs?
Yeah.
So that is basically you destroy a atom and you make that atom into a new atom.
Oh.
And in the process, some mass is burnt or some mass is converted into energy.
Yeah.
Okay. And that energy is huge. You have heard about the Einstein's famous equation, E is equal to
No.
mc square,
Oh yeah, I've heard of that.
right? So basically, what he is saying is if the mass is destroyed, it can be converted into energy, and energy can be converted into mass.
Okay.
Okay, any doubt?
No.
Okay, so
Wait, can you hear me clearly?
yeah, I can hear you clearly, no problem.
Okay.
If I have any difficulty in understanding, I'll definitely let you know. For now, it's very clear.
That's good.
Okay, then what? Then came the scientist that was J.J. Thomson. Okay, what J.J. Thomson was trying to do was he was trying to study how gases can conduct electricity. Okay, conduction of electricity through gas. So his objective was to understand whether gas can conduct electricity. Okay, so can you see that this is a glass tube over here?
Yeah.
Okay, so this glass tube is connected to two electrodes. Can you see that?
Yes.
Mm. So this is one electrode and this is another electrode. Okay,
Yeah.
then it is also connected to a pump, vacuum pump. Okay, so
Uh-huh.
so basically it has an option where you can fill the gas and then we can gradually reduce the pressure, and that means we can remove the gas and create vacuum. Okay,
Yeah.
does that make sense?
Think so, but why is a vacuum pump necessary?
So basically you can fill the gas and then you can gradually reduce the pressure. So once you have
Oh,
filled the gas in this, okay,
yeah.
then we like at different pressure, whether like what he wanted to see was whether at different pressure the gas is able to conduct the electricity, or there is some unique property how I can make gas conduct electricity.
Okay.
So in order to manipulate that, he used a vacuum pump or a pressure gauge to adjust the pressure. Okay,
Oh, okay.
so I should say pressure gauge. I called it vacuum pump. Let us say it's a pressure gauge to adjust the pressure. Okay,
Yeah.
then what I told you is that you fill the hydrogen gas over here, right? Let us,
Yeah.
I'm assuming hydrogen gas, okay? It's not necessarily that it's hydrogen gas. Okay. So let us consider first hydrogen gas. So uh, what J.J. Thomson did was he took this cathode ray tube or glass tube, right? And in this glass tube, he filled gas. Okay.
Okay.
After he filled the gas, he started reducing the pressure. Okay.
Yeah.
After he reduced the pressure, what happened was after some time he saw that there was a ray that emitted from the cathode and went to the anode.
Oh,
Okay.
yeah.
So he saw that there was a ray that emerged from the cathode and traveled towards the anode, right? Like this. Okay. So he
Yeah.
said that probably okay, it must be the hydrogen property. Okay. So what he did was he changed the hydrogen with oxygen.
Wait, I have a question.
Go ahead.
Is the plus anthode called a cathode?
No, the negative
Or
is
and
called as the cathode.
oh, why?
We'll come to that in electrochemistry. So
Okay.
you know cations,
Yeah.
those are positive ions.
Yeah.
So those positive ions are attracted to the negative, right?
So this cathode means like it attracts positive.
It attracts positive, yes, ions.
Okay.
Okay. Any doubt?
No.
So you have a cathode. So just for now, don't go into the names and other things. We are going to cover everything in detail. But for now, for the sake of uh, this particular unit, what you can remember is that this is a cathode, which is the
Yeah.
negative terminal, and this is the anode, which is the positive terminal.
Yeah.
Okay. Now, what did I tell you? That we had hydrogen, and as the pressure started reducing, he saw that. Then, from hydrogen, he decided that okay, maybe it's a hydrogen property. Let me try another gas and see what happens. When he took another gas, he saw the same phenomenon. Change the gas to another one. Change the gas to another one. He saw that if whichever gas I take, the cathode ray is emerging. So he thought that maybe it is something related to the cathode. Correct?
Yeah.
So what he started doing was he's changed the cathode from iron, let us say, to gold, to copper, to silver. But even if he is changing the metals, still he sees this ray. Okay? So he came to the conclusion that probably these rays which are emerging are fundamental to the element. Does that make sense?
I think so.
Right? What did I tell you? First, he took different gases, he saw the ray. Then he thought that probably it is a property of the electrode. So he changed the different electrode. Still saw the
So
ray.
so because it keeps the same result keeps on happening each time, it doesn't matter. Like it's the same for every
Yes.
single element.
Yes.
So they all have one same property.
Correct. So that
Okay.
is something fundamental to the element. That means this thing is present in all the elements.
Yeah.
Okay. So that was his first conclusion. Then he said that, okay, let me study what exactly the ray is. Then he applied the electric field to the ray. And he saw that the ray was attracted towards the positive electrode.
Yeah.
Okay, right?
Yeah.
And then he observed that these particular these ray which was getting was emitted was actually having some mass. So these are not radiations, but these are particles.
Mhm.
Okay,
Yeah.
so he was the first one who actually created particles from atoms. And he said that atoms can be broken. Does that make sense?
Yes.
Okay. So atom was broken and electrons were discovered. He named them as electrons.
Yes.
Okay. So,
Yeah.
so electrons are one of the fundamental particles of the atom. Correct?
Yeah.
Right? Can you take the screenshot of this particular part and save it somewhere?
Okay.
Extremely important concept. Okay. Done.
Not yet. Okay, yeah, done.
So what we have, what did J.J. Thomson do? J.J. Thomson, you can write down this, discovered electrons. So you need to write down discovered electrons. Second, you should write down cathode ray tube or cathode ray experiment. Okay.
Yeah.
Then the other thing that you should know is that I told you that he discovered the like mass, right? So it's not actually the mass, but he discovered the E by M mass, sorry, charge to mass ratio.
Charge to mass ratio.
Yeah, charge to mass ratio, E by M. And this was the way he said that, oh, it's a particle because it has some mass. But he didn't discover the mass, he discovered that it has charge to mass ratio. And he calculated that.
Do I have to write down the formula?
No, just write, yeah, that is not a formula. That is the value.
It says using the formula E over M equals negative 1.76,
Yeah,
etc.
Thomson was able to determine the mass charge to mass ratio of an electron using the formula E by M, right?
Yeah, but should I write the formula?
Yeah, I write it down.
Okay.
Done.
Yeah.
Then you need to write down one more part, that is the blueberry muffin model. Okay.
Okay.
So
Yeah.
now what is this blueberry muffin model? So, so I told you whenever J.J. Thomson comes into your mind, you should remember that he discovered electron, right? You should
Yeah.
remember the cathode ray tube.
Yeah.
You should remember E by M, and you should remember
E.
blueberry muffin model,
Yeah.
right? So now, what is this blueberry muffin model? Now, Thomson proved that there were negative particles that were present in the atom. Correct? He proved.
Yeah.
Correct?
Yes.
We know that an element is neutral. Correct?
Yes.
So if an element is neutral, right, then
Yeah.
that means there are positively charged particles present,
Yeah.
right? So he said that probably a atom is like a blueberry muffin, where the blueberries are the electrons and the sponge or the cake is the positively charged particles. Okay, and this was the structure of atom that he proposed. Make sense?
Yeah.
Okay, then let us go to the next, that is scientist Robert Millikan. Okay, what Robert Millikan then did was he discovered the mass of electron.
I write that down.
Yeah, you can write down. Who discovered that? Robert Millikan.
Hello?
Yeah, done.
Yeah.
Okay. Now, how Robert Millikan did that was his experiment was called as oil drop experiment. Okay, can you see there are three chambers here, one, two, and three. You are able to see my cursor moving, right?
Yeah.
So this is the first chamber, second chamber, and third chamber. So the first chamber, can you see this is oil, which has been sprayed into the chamber, first chamber, right? In the form
Yeah.
of droplets. These droplets are allowed to fall through this opening, which is called as the orifice, right? So the oil droplets are allowed to fall into the second chamber. When it is falling in the second chamber, you are bombarding that chamber with X-rays. Okay, why you are bombarding it with X-rays? Because then you are able to ionize them. Okay,
Mhm.
right? So once you ionize, what you do is you apply voltage between the two plates in the second chamber. You don't allow the oil droplet to fall to the bottom. Correct?
Yeah.
So now you know the mass of the oil droplet because you know the diameter of this orifice. So you know the mass and you know the charge. And you already know the E by M. Using this, he was able to calculate the mass of the electron. It involves a complex calculation. I'm trying to simplify it. Okay. So when it comes to Robert Millikan, what should you know? You should know about the that he discovered mass of electron. What is the mass of electron? 9.11 into 10 raised to minus 31 kg. No need to memorize it. And you should know that he was able to do it using his oil drop experiment.
Mm-hmm.
Okay. Then by the time this was getting discovered, okay, simultaneously there was another scientist, Madame Curie, right, and
Yeah.
Henry Becquerel, who discovered radioactivity, right?
Yeah.
So when they discovered radioactivity, they discovered that there are three types of particles: alpha particle, beta particle, and gamma rays. Two particles and one ray that are emitted from some radioactive elements. Okay,
Mm-hmm.
so alpha particle, beta particle, and gamma rays. Any doubt?
No.
Okay, so these are the properties of alpha particle. What you should know over here is that alpha particles are positively charged, right?
Yeah. Okay.
They are positively charged. The mass of that is 4. They are having low penetrating power. They are having low penetrating power.
What does that
Okay,
mean?
that means it can be stopped by a paper.
Oh, okay.
Okay, whereas beta particles are negatively charged, right? They are similar to
Yeah.
that of an electron. This is similar to that of helium. Speed
Yeah.
of them is fast. Medium penetrating power, can be stopped by aluminum. Gamma rays, right? They are rays, so there is no mass, no charge. Travels with the speed of light. Okay. Penetrating power extremely high. Basically, you need lead block to stop the radiations. Okay.
Yeah.
Can you take screenshot of table 1?
Yep. I took a screenshot.
Okay. Then let us come to the next. That is Rutherford's model of atom. Okay. So now why radioactive he understood is because he used radioactivity to discover the further what you say further intricacies in an atom. Okay. Hello.
Yeah.
So what Rutherford did? So Rutherford took the radioactive element and he put that in a lead box. So basically that lead box is like a protective cover. So the radioactive elements are allowed to pass only through this opening. Can you see there is an opening over here?
Mhm.
So through this opening, the uh, radioactive element was allowed to pass through a gold foil or bombarded onto a gold foil. So imagine that this is the alpha particle source. So this region is like a gun, okay, which is firing bullets. Okay, so imagine like it's a machine gun firing bullets at a rapid speed. Okay,
Yeah.
and imagine that this is a cardboard. So think, if you have a machine gun and if you have a cardboard, and if you fire the machine gun, like if you are firing the machine gun on a cardboard, what should happen?
Uh, Goes through.
It goes through, right? So that means what Rutherford said was, if J.J. Thomson was right, if his blueberry muffin model is right, then the 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 alpha particles, which are like the bullets, should easily pass through the what do you say, gold foil, right? And
Yeah,
everything should be over here. Does that make sense?
yeah, yeah,
Okay. What he observed, what he observed was that around 95% of the particles passed through the gold foil, but there were few which were deflected. Correct?
yeah,
This deflection is what surprised Rutherford. Okay.
mm,
Why? Because he said that my assumption was all the particles should pass through. How these small number of particles are getting deflected? That means this particular paper or the gold foil has something in it which is positively charged and which is extremely dense. Okay.
yeah,
Because there is something dense and positively charged, only because of that these alpha particles, which are like bullet, are getting deflected. Correct.
yeah,
Now, and the dense region is it's extremely small. Correct.
yeah,
If it was large, it's extremely large, none of them should have been passed through it. 95% of the particles are passing through it, means this particles, like these positively charged particles in the gold foil, are extremely tiny. Correct? Any doubt?
no.
Okay. So now what I want you to do is, I want to you to take the second screenshot, figure 8.
Wait, can you go back to the previous thing?
Yeah, yeah, sure.
Wait, so the alpha particles, are they positively charged?
Yes.
So why are they being deflected to the positively charged
They are not deflected by positively charged. What I said is, because they are getting deflected, that means the gold foil has something positive and
oh
dense. Correct?
yeah, okay.
Because it is dense, it is getting deflected.
Yeah, that makes sense. Hello?
Yeah. Any doubt till here?
No, I
So,
understand.
so Rutherford's experiment is clear. So this is what is his experiment, which is called as the gold foil experiment. Okay. Interesting.
Yeah,
Okay. And I want you to read this.
Rutherford did much of the early work characterizing radioactivity at McGill University. He received the Nobel Prize in Chemistry in 1908.
Yeah. So he did this research in Montreal, Quebec.
Yeah,
Yeah. Okay. So now this was his assumption. The other figure 8. I want you to take the screenshot of this too later on. But remember, if what was his assumption? If J.J. Thomson's experiment was correct, All the particles should have passed through the atom. All the alpha particles should have passed through the atoms. But his observation was there is something dense positive. Because of that, the particles are getting deflected. Correct?
Yeah.
Can you can you take screenshot of this, or you can even draw this? Nothing wrong in that. Okay, either way, a quick rough what do you say figure is also fine.
Okay, I took a screenshot.
Okay, and that's fine. But is it clear? Rutherford predicted alpha particles would pass right through the gold foil if Thomson model was correct. The actual
Yeah,
results of
makes
Rutherford
sense.
experiment revealed that the atom is mostly open space with a small positively charged center that contains bulk of the atomic mass.
Yeah.
Done?
Yeah.
Okay, so now I want you to write down this part. Okay, so based on this, and like not don't write it now. Based on this experiment, what Rutherford was able to conclude, right? That atom was having something called as a nucleus, which is dense and positively charged. Okay, he proposed that electrons moved around the nucleus at a relatively far distance, similar to the planets orbiting the sun. Rutherford later named the positive charges in the nucleus protons. Okay, then there was
Yeah.
another scientist, that was James Chadwick, who discovered neutrons, because he did some experiment and he saw that the observed mass of the elements were different than the predicted mass. So the to in order to adjust them, then he proved that okay, that there are neutrons that are present in the nucleus. Okay, so I want you to write down this: nucleus, protons, and neutrons.
Like which part? The part on the right or the part where they discovered it?
Yes, this. Okay,
Oh,
and I'll underline Rutherford concluded atom was with a nucleus. What is nucleus? Dense positive atomic charge. He Then he proposed that electrons move around the nucleus at a relative similar to that of planets orbiting the sun. Rutherford later named them as nucleus protons, and Chadwick discovered electrons. Sorry, Chadwick discovered neutrons. Done?
yeah.
Easy?
Yes.
Okay. Then The next one that you should know is we'll focus on figure 9. Can you see there is a ball bearing this girl is holding, right?
Oh yeah.
And there is a stadium behind her, right? I believe that is a rugby stadium, correct?
Maybe.
Yeah, football, like American football.
Yeah.
Okay. So now this ball bearing is the nucleus. Okay.
Yeah.
And the stadium behind her is the size of that atom containing this nucleus.
Mm-hmm.
Okay. So the image is trying to represent or trying to tell you that how tiny is the nucleus in comparison to the atom. So the atom is huge and the nucleus is tiny.
Okay.
Does that make sense?
Yeah.
Okay. Any doubt till here?
No.
Then I want you to take screenshot of table 2 and we just have you just have to read it later on. Nobody will ask you.
Yep.
Okay, done.
Yeah.
Then I believe you know all this, right? What are isotopes? What is atomic number? What is mass number? Do you know it?
Yeah.
Or you want a revision?
No, I already know it.
Okay, then I want you to copy this. Isotopes are atoms with same number of protons but different number of neutrons. Examples, I can give you one example, although you said you know it. It's better I give you example. Carbon 12, carbon 13, carbon 14, right? Atomic number is
Yeah.
666. Okay, so the atomic number Z is 6 for each of them. The mass number is 12 for this, 13 for this, and 14 for, sorry, the atomic number is 6, mass number is 14. Correct? Right? So your proton number is 6, 7, and 8. That is my bad. Neutron number or the number of neutrons. So the neutron number is actually mass number minus the atomic number. Can you write down this part?
Uh, I finished writing it down.
Done? Okay. So you wrote this. So you know what is an isotope, atomic number, the number of protons in the nucleus, mass number is the total number of protons and neutrons in the nucleus. And you should know whatever is the atomic number is the number of protons as well as the number of electrons. But for the definition's sake, why don't we consider electrons is because uh, electrons are something which can be exchanged, sorry, which can be given or taken to form ions. So the electron numbers at times may change, but the proton number for a particular atom doesn't change
Yeah.
unless and until it is a radioactive element. Okay,
Yeah.
that's done then. So I told you about this radioisotopes. An isotope that emits radioactive gamma rays or subatomic particles. Okay. One more thing that you should know is if the ratio of the proton to neutron is 1 is to 1, generally they are not radioactive. But if the ratio is greater than 1.4, it starts becoming radioactive. Okay, I may not be right with the exact ratio. Let me confirm that. Yeah, 1.4 is right. So basically 1.4 is for heavy elements. Okay, and it's fine. Like, so you should know this, right?
I should?
You should remember this. Like, there would be no questions on this, but it's better to remember.
Okay.
Okay.
Yeah.
Okay, in that case, let us conclude for today. I hope you have understood whatever has been done today. And from the next class, I think we are done with the entire nature. Okay, then we'll enter into the nature of, like, as we studied about radioactivity, right? To understand further concept, we should first understand what are the classical theories of light. We'll understand light, and then we'll try to understand how this light was helpful in understanding how the atom or the atomic structures are. Okay.
Yeah. I remember doing this last year.
Yes. So, as you remember now, for today, we studied about J.J. Thomson. We studied about Dalton. After Dalton, we studied about J.J. Thomson. After J.J. Thomson, we studied about Rutherford, right? Actually, we
Yeah.
studied in between, we studied about Millikan, then Rutherford, and Rutherford gave us the structure of atom, where he stated that atom consists of a nucleus which contains protons. Electrons are moving around the uh, nucleus, similar to that of the planets are revolving around the sun. So it's also called as the planetary model of an atom. Okay.
Yeah.
So with that, we'll conclude today's session and we'll continue next week, same time.
Okay. Bye. See you next week.
Yeah. Bye, Arnav.